there. Today we're going to look at areas of circles and sectors. Circles should be, I'm really not going to spend any time on it. Here it is, area of a circle. You should have done that in the past. That's the easy one. Sectors, and actually we have something we call segments. We're going to look at the area of finding both of those in this video. The sector in a circle is something like a piece of pie or piece of pizza. It's a section of the circle. If you consider how to find the area of a sector, it's really not that tricky. You're kind of comparing it to the area of the full circle. Well, in this case, let's pretend this was like a right angle in here. Could you compare the area of the sector versus the area of the whole circle? Well, I'm guessing it would be a fourth of it. And then, so if I could find the area of the circle, I'd take a fourth of it. Boom, I've got the area of the sector. All right, it is kind of like that, though it's not always as easy as it's a fourth of the circle. But the concept is the same. To find the area of a sector, it's always going to equal the portion of the circle that you're using. In this case, I've got a 90-degree angle. I'm comparing that to all the way around. So it's like 90 over 360, which happens to reduce to 1/4 in this example. They don't always reduce, sometimes they do, but this idea right here, this is what we're going to use. Instead of it being a 90, I'm going to call it the central angle over 360. Whatever that ratio is right there, I'm going to then take that ratio times pi r squared. And that'll get me the portion of just of the area of the circle that I want. Go ahead and jot down that formula. That's what we're going to be using today. Let's try an example of it. And it says a circle has a radius of 4 inches. What is the area of a sector bounded by a 45-degree minor arc? Leave your answer in terms of pi. Remember, sometimes we like to leave the answer with pi sitting in there. Sometimes we go ahead and type in the 3.14 or use the pi button. Here we're going to leave pi there. So I'm going to start off with the area of my sector is going to be the portion of the circle I'm using, which is 45 out of 360 degrees. Multiply it by the area of the circle, which is pi r squared. The radius is 4. So that's tight. And what I'm going to do here is I'm going to try to do some reducing first. The 45 and the 360 actually reduces very nicely. It actually reduces to a 1/8. Times, think of this kind of like we've done in the past. Let's make a bunch of fractions. If I'm going to have to reduce it, let's leave everything kind of in fraction form. That way I can reduce easily. This actually simplifies quite nicely. The area of this sector is going to be 2 times pi. It's area still, so you're going to square your units. There you go. The next part of our lesson is on finding the area of a segment of a circle. And that's not a segment like we think of in the past, but in a circle, when we have this little, we call this a chord, and it cuts off a section of the circle here. And when this chord, which is that segment, cuts off this area in here, is the segment of a circle. Now to find that, we're going to be using the area of a sector. So I'm going to start off, and it's like I'm doing this sector, but then I draw this chord in here. Now what I'm wanting is this piece right here. If I find the sector, that's too big. What I have to do is I have to subtract out the triangle piece that I don't want, and I'll be left with the segment that I do want. So overall, there's your formula. Take the area of the sector, subtract the area of the triangle, it's going to be the area of the segment. So this we just practiced. This we've done in the past. There's our new answer. All right, here's a problem where we have to find the area of that segment. I'm going to start off, and I'm going to find the area of the sector, and I'm going to subtract the area of the triangle, and that'll be my answer. Let's start with the area of the sector. The area is equal to, now what portion of the circle am I using? I'm using 60 degrees out of 360. Multiply it times pi times the radius squared, 18 squared. Okay, then I'm going to subtract the area of the circle. The area of the triangle. Area of a triangle is 1/2 the base times the height. Now if you look at this, all right, this is a 60-degree angle. I'm going to drop the height in that triangle, and what that's going to do is turn that into a 30-degree angle when I do that. And here's a 90, and what do you know? It's a 30, 60, 90. They never go away. The special right triangles, they're always there. The hypotenuse is 18 in that special right triangle. So let me redraw that so you see what's going on. This is the 18. This is like the apothem, or the height of the whole triangle. And that's kind of what I need to know. I need to know that full height. I need to know this piece. And to be honest on this, we really could, well, let's just move ahead. As a side note. Okay, I'm going to go ahead and stick with my 1/2 base times height. And the base is this full length of the triangle. And then the height of the triangle is this right here. That's the long leg. So let's go back to my 30, 60, 90. If the hypotenuse is 18, the short leg is 9, the long leg is 9√3. So if I'm putting this information up here in my formula, 1/2 the base, that's the full length right there. That'd be 9, but I'd have it doubled because there's 2 of those in there, so that'd be 18. And then the height is 9√3. Now the directions here say to round to the nearest tenth. I'm going to clean this up a little bit. I'm a little bit nervous about doing all of this in my calculator. Let's see what happens here. My 60 over 360, that can reduce. The zeros go 6 over 36, 1/6 times pi, and then I have 18 squared. 18 squared is 324. Okay. Minus 1/2 of 18. I like that mental math. Half of 18, that's 9. Times 9, that's 81√3. Okay. I think I'm going to be okay to enter this in my calculator as is. I could reduce if I wanted to, because I'm pretty sure that 6 goes into 324. I'll check that. Oh, look, it does, 54. So I might as well reduce that. Then I don't have any fraction whatsoever. I'm going to write that and clean it up right here for us. Area is going to be 54 pi minus 81√3. I kind of wanted to show that to you, the simplifying, in case the directions ask for an exact answer. That's what you'd have to enter for your exact answer. All right, as a decimal, I'm going to type in 54 times pi and minus 81 times the square root of 3. And if I do it all in one shot, left to right, it will keep track of my order of operations for me. I get an area for that segment of 29.3, yep, 29.3 inches squared. All right, let's look at one more example like that. Again, looking for the area of the segment. I'm going to have to do the same thing I did before. I'm going to do the area of the sector, and I'm going to subtract the area of the triangle. Area of the sector formula is going to be the portion of the circle that I'm using, which in this case is 90 over 360 times pi r squared, minus the area of the triangle. Area of a triangle is 1/2 the base times the height. Now, the base is this length. The height is this right here. I take that 90 and I drop that height, and it takes it and turns it into a 45 with the 90-degree angle that I dropped. Another special right triangle. It's a 45, 45, 90. It's going to look like this, where the hypotenuse is 4. Do you remember what you have to do to the hypotenuse to get to the short, or to get to the legs? That's right. You got to divide by √2. Divide by √2. Rationalize it. 4 root 2 over 2, and then the 4 and the 2 can reduce, and I'm left with 2 root 2 for the side lengths. Now when I look at my triangle, the side lengths here are this side and this side. So that it's given me the height of my triangle. So my height is going to be 2 root 2. But I want the full base. This much is 2 root 2. So the whole thing is 4 root 2. The base is 4 root 2. Height is 2 root 2. Let's plug those in. The base was 4 root 2. Height was 2 root 2. Now let's clean this up and simplify. I know that 90 over 360 is going to reduce to a 1/4 times pi times 16. Just in case it asks you on your homework, I'll go ahead and do the kind of the reducing of the fraction. Otherwise, you can just type it into your calculator as is. This is where it gets nice though, because you end up with this root 2 times another root 2. Remember, the order I do this doesn't matter. I'm just going to kind of pick and choose. This root 2 times this root 2 is just a 2. So I have a 1/2 times a 4 times a 2 times another 2. All right, that's a mess. I'll go ahead and just write it. 1/2 times a 4 times a 2 times another 2. All right, let's do some cleaning up. This 4 can reduce with this 16. So that's going to be 4 pi. Over here, half of 4 is 2, times 2 is 4, times 2 is 8. So it's 4 pi minus 8. Typing that into my calculator so that I can get an approximation for that. I get 4.6 meters squared for the area. What do you think? Is that doable? It's kind of, the sector part is the kind of the easy part, and then the area of the triangle pulls back a lot of that previous stuff that we've learned. This slide is kind of a recap of the 3 different things that you're going to have to do on this homework. What I'd really like for you to do is pause the video right now, go see if you can do these 3 problems. Then come back and check your answer. So take a minute right now. Pause. I can wait you out. I really can. Go ahead and pause. All right, go ahead and take a moment and check your answers. If you agree with me, then you're a genius. Let's move on and go do your homework. If you don't agree with me, then you're still a genius. You're just in the making. Let's go ahead and check, and we'll go through each one of these and see if you caught some things. All right, so on this first one, did you catch that they gave us the diameter instead of the radius? So when you did pi r squared, you should be using an 8 there. All right, down on number 2, this one was kind of your straightforward. You just had to make sure you had to reduce everything because your answer didn't really end up very pretty for leaving it in terms of pi. So this is what it should reduce to though. This to get here, I divided both of those by 15. That's how I got down to here. And then I could reduce a little bit more with the 81. All right, last one, number 3. They kind of gave you the angle a different way. They gave you the measure of the arc. But remember that the measure of that arc is the same as the measure of the central angle. So the central angle was 120. Drop that, it's now 60. Get yourself a 30, 60, 90. Radius is 2. Short leg is 1. Long leg's 1 root 3. Plug in the numbers here. Again, this didn't reduce great, so you kind of have to leave it. And then you have to subtract the root 3, and that just has to be left there also for an exact answer. All right. Hopefully this helps out. Good luck.